Hey guys, in this lesson we would understand how to evaluate limits that are indeterminate. Indeterminate limits are limits where direct substitution does not work. So we figure out different ways to calculate the limits. We will understand indeterminate limits with the help of examples. The first example is when we are supposed to find out limit x approaches to 2 for 4 minus x squared over 2 minus x, and we try direct substitution on it, and let's see what happens. First, we're going to split it up using the properties of limits. When we apply the properties of limits, this is how we split it up, because the first one is a constant, so we will write it as is. The second one, we're going to do substitution on it. This is a constant, goes as is. This one is a substitution. So this would give us 4 minus 4 over 2 minus 2. That is a 0 over 0 limit. 0 over 0 is what is called indeterminate limit. If this is the scenario and we end up with an indeterminate limit, then the solution to this is we find an equivalent function that is same as the original function for all values except x is equal to a. What does this mean? Let's understand this in simple terms. That means we have to rewrite this function in an equivalent form that will have all the values of fx same as this original function, except when we are finding the fx for x equal to 2. In other words, when we substitute x equal to 2 in this function, we get 0 over 0. But if we rewrite this function in another equivalent form and then we substitute x equal to 2 in there, we get a different answer. And that answer will be the limit for this function as well. Now the process to find an equivalent expression or an equivalent function is either factoring the given function or rationalizing the given function or changing the variable of the given function. So out of these three methods, we're going to adopt the one method that is applicable to that particular function. What does that mean is, now this is a function on which rationalizing is not applicable. Changing the variable we can always try at the end. So we would first try factoring on this. Let's rewrite the question. So the question was limit x approaches to 2 for 4 minus x squared over 2 minus x. Since we're trying to find an equivalent function for this, we will not start evaluating it. Instead, we will start writing it in a different way. On this, we are trying factoring. Being a grade 12 student, the students are expected to know their prerequisite skills of factoring. So if we factor this, this is a difference of squares. That would yield us this. This would give us 2 minus x, 2 plus x, over 2 minus x. The common factor can always be cancelled out. So the equivalent function is this for this given function. To get the answer for the limit, we would redo substitution into this new function, and now we would solve it using the properties of limits. So limit x approaches to 2 for 2 plus limit x approaches to 2 for x would give us 2 plus 2, because here it's a constant and here we're going to substitute 2 in place of x, and we would finally get 4 as the answer. So this was the example to understand how to evaluate indeterminate limits when factoring is possible for the function. What if we are given a function where factoring is not possible? Let's take up that example as well. So let's say if we're given a question limit x approaches to 0 for radical x plus 1 minus 1, the whole thing over x. Let's try direct substitution on it and see if it works. I'm just directly substituting the x values. This is done to save the time. So it gives us root 1 minus 1 over 0. Root 1 is 1 minus 1 over 0. That would give us 0 over 0. So this ends up in an indeterminate root. That means this is a problem where direct substitution does not work. So either of the three options, factoring, rationalizing, or changing the variable, is going to be used to simplify this particular expression. In this case, because we have a radical, so rationalizing is the best option. As factoring, we can do factoring for the radicals. It's a complicated process. We always try to rationalize whenever we see a radical. Now let's understand how to rationalize a given function. To rationalize a function, we would see where is the radical. In this particular function, the radical is on the numerator. And on the numerator, we have two terms, 1 and 2. To rationalize an expression or to rationalize a function, we always take the conjugate of the given radical expression. What is meant by conjugate is, on the numerator, we have square root x plus 1 minus 1 as the two terms. The conjugate is the similar two terms but with a opposite sign. So instead of negative, we would have a positive. So this is called the conjugate of this expression. Now we would use this conjugate to multiply and divide with the given function, and that would look like square root x plus 1 minus 1 over x multiplied with square root x plus 1 and divided by square root x plus 1 plus 1. Again, you guys are expected to know your factoring. So we notice this is a minus b, this is a plus b. As we know, a minus b times a plus b gives us a square minus b square. So we can apply that here. That would give us x plus 1 radical square minus 1 square, the whole thing divided by x times square root x plus 1 plus 1. The square and the square root gets cancelled out. We are left with x plus 1 minus 1, and on the denominator we would have x times root x plus 1 plus 1. Plus 1 minus 1 cancels out. We are finally left with x over x square root x plus 1 plus 1. With that, this x and x can also get cancelled out because of the common terms. And finally, the equivalent function will be 1 over square root x plus 1 plus 1. Now the original question that we were given was to determine the limit on this particular function. This function has now been changed to an equivalent function that can be written as limit x approaches to 0, 1 over square root x plus 1 plus 1. After we have turned it into an equivalent function, we would again try substitution on it. And when we simplify it, we see that we're able to work on the solution, because square root 0 plus 1 is root 1 plus 1, which is 1 over 1 plus 1, which is 1 over 2. And this is the solution for the limit for this particular question. Moving on to the next example. Let's say if we are asked to determine the limit x approaches to 8, where we are given the cube root of x minus 2 over x minus 8 as the function. Since this is our function and the radical is a cube root, when we look at this function, we notice that this type of radical cannot be rationalized. Neither it's easier to factor this out. So we would try the third method, that is changing the variable on this. How do we do that is, we're going to take this complicated variable, that is cube root of x, and rewrite it as another simple variable. Let's pick variable a. It's up to you whatever alphabet you want to pick up. You can use that. But I'm going to show you example with a. If I was trying to substitute x, then I would simplify it as x is equal to a to the power of 3. Reason is, the cube root of x means x to the power of 1 by 3, and that is equal to a. So when 1 by 3 goes on the other side, it becomes cube of a. This is one thing we have to remember, is that if we are changing the variable on any one of the terms in a given function, then we have to change the variable for every term. That is here, here, as well as here. So if you're writing this in the form of a, this has to be written in the form of a, as well as this has to be written in the form of a. Now the first term, that is this one, can be written in the form of a as is. The second term, that is this one, can be written in the form of a like this. To get this one written in the form of a, we would have to solve for a when x is equal to 8. Since we initially took cube root of x is equal to a, we're going to substitute x as 8 in here. When we simplify this, a gives us a 2. Now using these three terms of a, we're going to rewrite this function in an equivalent form, and that would be limit a approaches to, where cube root of x is written as a minus 2 and x is written as a cube minus 8. After this, if we try direct substitution and substitute 2 in here and 2 in here, so we would get 2 minus 2, that is 0, and we would get 2 to the power of 3, that is 8 minus 8, again a 0. So we will again get an indeterminate root in this case. So in this case, we are using more than one way to write down an equivalent expression. Going from here to here is called changing the variable, and after that we will be using factoring to rewrite it in a form that can be used to evaluate the limit. The reason we are using factoring is that we noticed a cube minus 8 can be factored out using the formula a cube minus b cube. That can be written as a minus b times a square plus ab plus b square In this case, a is a already. B can be written as 2 to the power of 3. So we would have a minus 2, a square plus a times 2 is 2a, plus 2 square is 4. And we can rewrite this here such that we get limit a approaches to 2 with the function a minus 2 over a minus 2 times a square plus 2a plus 4. When we see any common factor, we can always cancel it out, and we will finally be left with limit a approaches to 2 with 1 over a square plus 2a plus 4. Now, if we use substitution to evaluate, we notice we are able to get the answer. So we're able to get 1 over 4 plus 4 plus 4, which is 1 over 12. And this is how we calculate the limits when we have indeterminate limits. To summarize, we have three different ways to convert the given function into an equivalent function. The first method is using factoring, second method is using rationalizing, and the third method is to change the variable. We're going to use the method that is applicable to a particular question in order to rewrite it in an equivalent function. And once we get the equivalent function, we're going to again do the substitution in there to get the final answer.